Hey, what's going on? Welcome back. Today we're going to continue on what we said we were going to do in the last video. We were going to improve on the two sums program that we wrote. As you can see, we're back inside of LeetCode. Two sums problem, that's what we're currently working on, and that's what we're going to improve. And if you remember, given an array of integers, return indices for the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. And it gives our example there. And we did submit it before our brute force method, and it all passed, so we know that works. And again, we are going to improve the performance on this. It's 2 for loops equals n squared. Very bad if the number gets extremely large. So let's go on over to Paint, or our Paint software, if you will, to write out a solution to this. Alright, here we are in Paint. So let's go ahead and write out what we have for an array. 2, 7, 11, and 15. So if we have this array, right, the last time we went through, we started this index and then we looped on every one after to see if, you know, this index plus this index equals our target. If it didn't, then we check to see if our next index, you know, and dot dot dot, then we go, if that doesn't do it, then we go 1 plus 2 equals target, dot dot dot. So that required 2 for loops, because you had to set the index there at I, then we had to set an index here at j, then we loop over j, and then we loop over I, and then j again. So, you know, that got really crazy. It got up to n squared runtime, which can get awfully big if you have a large array. So since we're using C++, we can optimize this with any code, but C++ offers a map which can come in handy, which can decrease the runtime of this problem. You know, not substantially, but enough to make a difference. We can actually drop it down to just n, which still can be quite large, but not as large as n squared. So how we go about doing that, C++ offers this thing called a map, and we can store this array into a map, so we can loop over it. We can loop over this, the 2, 7, 11, 15, and we can store that inside of a map with the index. So if we have a for loop, so we just say for, int I is equal to 0, yada yada yada. Then we can say, our map can, we can add, this. So we would go, an array. So let's make this so this is more clear. So nums is equal to that array. Then we can say that I, and then its key, or that would be the key, and this would be the pair. The pair would be I. So it would keep our index that it wants, and we just have a for loop there. So basically all we're doing is just adding this to a map, setting the key to these values, and setting the second value to I, the index. So all we have to do is simply return this if it contains what we're looking for, and then all we have to do is just loop over it again, loop over the map, for map. We can check to see if our map contains, I'm sorry, first let's go back. Let me go ahead and erase this. We can actually, we don't have to loop and check to see if if these two indices match to equal the target. We can actually just set it to complement. So we can go comp is equal to the target minus nums I. So we still do need the for loop, so I'll just write for. It's very sloppy handwriting. So for the for the size of nums, or the map size, they should both be the same size, doesn't matter. We can find the complement. So if we take the target is equal to 9, and our num index is 2, 9 minus 2 is equal to 7. So if the map contains 7, just return, the map second, along with nums, just I. And we return these two, return, very sloppy handwriting. So now we just have one for loop up here. These two, instead of adding, multiplying them with nested loops, you just n plus n is equal to n. It is a one pass or two pass loop because you have to loop through the map, add this to the map, and then we have to go back through the map to check to see if we contain the complement. And if it does, then we can just simply return out, because we no longer need to look any further. So let's go ahead and jump right into the code, because it'll be a lot more easier to explain than trying to write it out. So let's head on over to do that. See you back in a bit. Alright, here we are in the code. We've written it out. Same as before, same function, same main, where the target's set to 18, same array, 2, 7, 11, 15. Come here to two sums, pass it the same array and the same target, but this time we're creating the map, the data types of int, and then we have our temp vector, hasn't changed, but this time, as we showed in the drawing, this is our first for loop. We run up to nums.size, we we make a pair of the nums I, the element in nums I, which would be num0, which would be 2, and I, which would be 0, because I is equal to 0. And then we loop over for each one, so then 7 would go here, and 1, and 2, or 11 and 2, and we do that until we get to the end. Then we fall down to this for loop, we run up to nums.size, and we find our complement. We say target minus nums at index I, which would be 18 minus 7, we get 11. If we can find 11 in the map and it doesn't equal the mapped n, then we can return the index, and then we can return our element at 11. So then this will return 2, so you get 1 and 2. If it's not in there, then we just loop back over again, and then until the end of our array. And we can see that this works by running it. We get 1 and 2, exactly what we're looking for. 7 and 11, 0, 1, 2, 1 and 2. Let me go ahead and try something else. 2 and 7, we can make it 9. We get 0 and 1. So that's all that's to it. Pretty simple. Exactly like the drawing. 2 for loops, not nested, kind of in sequence of each other, which does improve runtime. But yep, that's all there's to it. Pretty simple, straightforward program. And we'll move on to a new challenge in the next video. See ya!